Hey guys, it's your friendly neighborhood engineer here, back with another lesson. I want to point out some things that people just don't know about nuclear power, and it's very important. And if you're already watching my channel and you're around my channel, then this is the subject that I choose to cover. So I kick a dead horse around here a lot, but it's very important to understand how the conversations go and the information you can pick up on. Trying to not only show you this information, I'm also showing you how to use it. Okay? So we're just going to read through this one person's comment. It's not very long. And we'll see what we can come up with. Okay, it says, on average in a year, PWRs release around the same amount of radiation equivalent to potassium-40 that is found in 6 people. That is almost nothing compared to coal or gas power plants, which I don't believe that's true, but I digress. I said, show your work. I said, then does how organically bound tritium cause DNA strand breaks, micronucleus formation, cell necrosis or apoptosis, chromosal aberrations, and various other phenomena, thus negatively affecting human health, if it's the same as potassium-40 in a banana? The 2007 Vogel, Georgia study from the Blue Ridge Environmental Defense League showing clearly a before and after difference of not only cancers but beta negative decay in the drinking water. So no, that's wrong. It says tritium and potassium-40 both beta decay and both are part of other organic molecules. When decaying, they both damage your cells. Your cell DNA is being damaged all the time by various things, not only radiation, and the damage is being repaired constantly. Yes, we know. I will say I've enjoyed these conversations, but guys, don't always just assume that nobody knows that DNA is damaged every day, and we all know this. This isn't a secret. This isn't something that only the medical people know, or the physicist, or this or that. We all know it. DNA damage happens, and then it's repaired. But if more happens than is repaired, then you have issues, as they point out. Okay. As long as the damage to DNA is lower than repair capabilities of your cells, you are fine. See, the dosage here is key, which is true, to know if it is dangerous or not. If you are worried about damage to DNA, then consume more antioxidants and phenols, which is great information to share. That's perfect. Okay, tritium is not the same thing as organically bound tritium. Organically bound tritium is tritium that is taken up in the food, vegetation, fruits, grains, and we feed our chickens, pigs, cows these foods that then is ingested by us. So it's not only our external exposure or like eating a banana, because the energies are different. It doesn't matter if they're both beta decay. What is the EV of potassium-40 versus organically bound tritium H3O? How many joules of each, please? And then they said something in between here that they erased something about saying I was scared about radiation and all this, which isn't true. I'm not scared of radiation. I know it's around me at all points of the day. Okay, I understand that. It's the dosage. It's the time. Time after time after time you get dosage. It adds up. It adds up. It keeps adding up. I said I'm not scared of it, see, and know much more than you will ever admit to. I know because with your knowledge, you too must make money in some way or fashion. I said, yes, naturally it occurs, but so does arsenic, so does lead, so does murder. All happens naturally. So does that mean we should add more to the environment and then tell the public that tritium is usually excreted from the body in under a month and most times within 12 days? No, that is an outright fabrication made by the International Atomic Energy Agency, the World Health Organization, the Nuclear Regulatory Commission, the Center for Disease Control, the Environmental Protection Agency, the Department of Energy, politicians, corporations, CRADA agreements, which is important. If you don't know what those are, look those up. and so on, which absolutely sways the public's perception on nuclear power. This isn't by far the only issue with nuclear power, but is one of many of the main issues surrounding this entire industry throughout history. Hanford, Westlake Landfill Superfund Site smoldering vent, which I'm going to do a video on here coming up next, I think. It's all causing unneeded exposures for a mere 10% of the global energy market. That is corruption, period, and you further prove me correct being here trying to make it seem otherwise. He says, I didn't argue it's harmless because it's natural. I argued that amounts are too small to matter. It's de minimis. When some power plants in a day release 100 times less becquerels of tritium than there are potassium becquerels in our body, I can't see how people can hold it as an argument against nuclear power plants, especially if instead of nuclear power plant, people build coal power plants, which is not true. The coal plants of today are not the coal plants that everybody argues thinks they are. This is not the 1920s. The filtration systems are completely different. Okay, I said, yes, I know what you're arguing, but what you're not even contemplating is the difference between potassium-40 radioactive potassium and tritium H3 radioactive hydrogen aren't the same things and will not be taken into the body the same way. Not everyone eats a banana or takes in large amounts of potassium-40, but everyone drinks water, eats plants that take in water, and eats animals that drink water. The energy doesn't matter because potassium-40 isn't used in the world as water, rain, condensation, evaporation, with tens of thousands of terabecquerels released from each site annually. That's the difference. Until you're honest with yourself about those differences, then you will never come to the correct conclusion. He says, I have made a mistake in converting tritium released to potassium-40 in humans. And, well, that's what you get for trying to convert one thing to another, apples and oranges, okay? 700 curies is not equivalent to 6 people. It's 6 million, okay? That's what I get for doing math late at night. Now that I spotted my mistake, the universe is making sense once again. Right, okay. All these days, I had a feeling that something is not right here. Oh well, why didn't you notice that I was wrong by a factor of 1,000,000? Well, why would I fix your math for you? Come on. I get around 0.4 microsieverts a year from potassium-40 in my body. How much do I get from tritium? When you get the answer, you will know why I consider tritium released from power plants as de minimis. This time I looked up scientific papers on tritium exposure. Okay, well, what were those scientific papers and who put them out? What was the data set and what were the factors they used? Okay? Just because you looked up one study doesn't mean you know exactly how much tritium you have inside of you. I said, as with anything, it's not with one thing. Carbon-14, krypton-85, and xenon-133, iodine-131, particulates, and an other category. Tritium is one piece of the puzzle of showing how nuclear power shouldn't be used. You think about tritium one specific way if you like, but make sure you add them all together to get the whole picture instead of just one puzzle piece. That's very important, guys. This stuff all adds up at the end of the day, at the end of the year, and at the end of your life. That gets cut shorter. It says, yes, you have made a mistake in trying to compare tritium to potassium-40. Again, you're stuck on the specific MeV that they produce, not noticing the bonding energy or the excess energy, or that, again, the potassium-40 is not falling from the sky as the tens of thousand terabecquerels of tritium would. We aren't talking about one tritium or one organically bound tritium radionuclides. We are talking about a large amount of those one tritium radionuclides. One after another, day after day, year after year. It's cumulative, and being organically bound, it works its way up the food chain. There is no mystery or issues with late-night calculations because they will never add up to what's occurring in real life. And this is what's occurring in real life. In Vogel, Georgia. They took measurements before the site operated and in preparation for this 2007 study. Okay? And they found the increases of each of these. We're talking plus 44.6% increase from what it was back in 87 to 90 compared to what it is in 2007. During the same period of time, the cancer death rate for children and adolescents rose 58.5%. That's nearly 60% increase to a 14% decline nationally. Can you really argue this anymore? Can anyone argue that tritium is like a banana or less than a banana and is harmless? No, you can't argue it because, as I said, your calculations on a piece of paper do not add up to real life and never have. All right, guys, thanks for watching. Put your comments down below and watch for more. All right, bye.